Hey everyone, I'm Robbie.
And I'm Rosie.
Welcome to our deep dive into the robot revolution, and a huge shout out to Mr. Wheeler's automation and robotics class for making this happen.
So, are you ready? Get your gears turning? Let's do it.
Okay, let's be real for a second. Have you ever, just stared at a sink full of gross dishes? Or maybe a chore you absolutely dread and just thought, man, I wish a robot could just swoop in and take care of this. Yeah, me too. And believe it or not, that's kind of the whole reason industrial robots even exist.
That's absolutely right, Robbie. In the world of industry and manufacturing, it all comes down to what we call the 4 Ds. First, you've got jobs that are just plain dull. We're talking about tasks that are so repetitive they can be honestly degrading for a person to do all day. Then there are the dirty jobs. Think disgusting, messy, or working with hazardous materials. Of course, you have the dangerous ones, where there's a real risk to a person's safety. And finally, dear, which just means the task is way too expensive or difficult for a human to do efficiently.
So, what's the answer to all those 4D problems? Well, meet the modern workhorse, the industrial robot. And we're not talking about your sci-fi sidekicks here. These are serious machines, and one of the most important names you need to know is FANUC.
Yeah, FANUC is a massive leader in this field. You've probably seen their signature yellow robots without even realizing it. They are the absolute backbone of countless factories building everything from cars to your smartphone. Their whole purpose is to make production faster, better, and most importantly, safer for all the humans working there.
Now, it's super important to know that robot isn't just one thing. There are different types for different jobs. You've got articulated robots, which look a lot like a human arm and are amazing for general-purpose stuff like welding. Scaro robots are built for incredible speed and precision. Delta robots, they're lightning fast at picking and placing things. And then you have collaborative robots, or cobots. These are really cool because they're designed to be in a full safe state, which means they can work right next to a human operator without needing those big safety cages you usually see.
Okay, time for some key terms. Let's get a grip on this one. An arm's not much good without a hand, is it? That's what we call the end effector, or end of arm tooling, EOAT for short. It's the business end of the robot. It could be a gripper, a drill, a paint sprayer, basically whatever tool the robot needs to actually do its job.
And the way they move is all about their dexterity. I mean, look, I've got 1, 2, maybe 3. Ouch, okay, that's not working. What he's trying to show you are the degrees of freedom. It's basically the number of different joints a robot has that can bend and rotate. Your arm has about 7. Most industrial robots have 6, which is just enough to give them the flexibility, or dexterity, to reach almost any point in their work area from any angle. It's pretty amazing.
So, we've got these incredible pieces of hardware that can move in all sorts of ways. But here's the thing, they don't know what to do on their own. They need a brain, they need instructions, and that's where programming comes in.
And this is my favorite part. It's not magic, it's simulation. Think about it like you're building the most epic level in a video game. Before a single real part is ordered, engineers build the entire factory inside a computer. Using software like FANUC's RoboGuide, they can program and test every single movement the robot will ever make in a totally safe virtual world.
Robbie's totally right, and it's a very logical step-by-step process. You start by picking your virtual robot and its tool. Then you bring in 3D models of all the other equipment, conveyors, tables, parts, everything.
Wait, so do they use like a virtual tape measure to get everything lined up?
In a sense, yes. They program exact coordinates, mapping out the robot's path down to the millimeter. The most important step is running the simulation over and over to catch any potential collisions and make sure it's all in a full safe state. Then, and only then, does that perfected code get uploaded to the real robot on the factory floor.
And this quote from FANUC really sums it all up perfectly. Using simulation software like RoboGuide is a total game changer. You can figure out all the problems and perfect the entire process without ever having to shut down a real production line or risk damaging millions of dollars in equipment. It's a hugely powerful tool.
Okay, so these robots are amazing, the software is genius, but they don't just appear out of thin air. Let's talk about the brilliant people, the masterminds, who actually make all of this happen.
Everybody, meet an absolute robotic rock star, Dr. Ayanna Howard. Her career is just wow. It shows you exactly where a passion for this stuff can take you. After getting her degrees, she went to work at NASA's Jet Propulsion Laboratory. Yeah, the place that builds the Mars rovers. From there, she founded her own lab, focused on how humans and robots can work together, and even created robots to study climate change in Antarctica. A true pioneer in the field.
So robots are tackling the dull, dirty, and dangerous jobs. Brilliant engineers are programming them to do incredible things. Which leads us to the one big, looming question that I'm sure we're all thinking. Are robots going to take all of our jobs?
Well, that is the million-dollar question, isn't it? And you can find some pretty startling numbers out there. For instance, one major study predicted that 38% of U.S. jobs have a high risk of being automated in the next decade and a half. Now, that number sounds really scary, but it definitely doesn't tell the whole story.
The future isn't about humans versus robots. It's really about humans with robots. It's a team effort. You have to play to everyone's strengths. Robots are unbeatable when it comes to brute strength, endurance, and mind-numbing repetition. But humans, the creative engineers, the skilled operators, we still own things like creative problem-solving, flexibility, and communication. The real goal is to let the robots handle the robotic work, which frees up people to do what we do best: innovate.
Exactly. Just think about it for a second. The job app developer didn't even exist 20 years ago. As technology moves forward, it doesn't just replace old jobs, it creates entirely new ones that we can't even dream of yet. So the real question we want to leave you with is this. As the jobs of today change, what amazing new jobs will you help create for tomorrow?
And that's all the time we have. We really hope this gave you a better window into the fascinating world of automation and robotics. A huge thank you to Mr. Weiler's class, and thanks to all of you for watching. Keep on building the future.